The ocean's wrath. Can anything survive? The ocean is a force of pure destruction. Towering waves, violent storms, capable of swallowing ships whole. Even the U.S. Navy's largest aircraft carriers, steel behemoths the size of cities, are not invincible. In the heart of a raging storm, these giants face an unseen enemy: the unpredictable power of nature. Waves taller than buildings slam against their hulls. Wind howls at over 100 miles per hour. Decks become slick, unstable battlegrounds where even the most experienced sailors struggle to stand. In these moments, a single miscalculation could send billions of dollars and thousands of lives into chaos. So how do these massive warships survive the ocean's fury? Is it raw power, engineering genius, or a hidden technology that keeps them afloat against all odds? The answer is more advanced than you think. And it might just be the key to winning the Navy's greatest battle, not against an enemy fleet but against the sea itself. The giants of the sea, aircraft carriers versus monster waves. They are the largest warships ever built, floating fortresses designed to dominate the seas. U.S. Navy aircraft carriers, stretching over 1,000 feet long, weigh nearly 100,000 tons. They carry fighter jets, missiles, and thousands of crew members, all operating in perfect coordination. These giants are engineered for war, built to withstand brutal battles. But against the raw power of nature, they face a very different kind of enemy. When the ocean turns violent, even these behemoths are tested. Waves as high as a 5-story building crash against the hull. Hurricane-force winds whip across the deck, making it nearly impossible for pilots to land. The ship tilts and sways, metal groaning under the force of the storm. And here's the terrifying truth. In extreme conditions, even a carrier can lose control. Rogue waves, unpredictable and deadly, have been known to snap ships in half. The relentless pounding of the sea can damage vital equipment, flooding compartments and throwing multi-million-dollar jets off balance. But the biggest danger? The carrier itself. When waves push a ship beyond its limits, it can enter parametric rolling, a terrifying phenomenon where the ship rocks violently from side to side, each movement getting stronger. If not corrected, the carrier could capsize. So how does the U.S. Navy fight back? How do these giants stay afloat, stay operational, and keep dominating the seas in the worst possible conditions? The answer lies in a secret arsenal of super technology, a combination of engineering, AI, and advanced stabilization systems that allow these warships to defy the ocean itself. But what happens when even technology is pushed to its limits? What happens when man and machine must stand against the most unstoppable force on Earth? The battle between aircraft carriers and monster waves is only beginning, and the Navy's survival depends on what comes next. The secret supertech that keeps carriers afloat. Aircraft carriers are floating cities, massive, powerful, and built for war. But against the raw force of the ocean, even these giants face a brutal test. Monster waves, rogue swells, and relentless storms threaten their stability. A single miscalculation could send billions of dollars in technology and thousands of lives into chaos. So how do these 100,000-ton war machines stay afloat, steady, and operational in the worst possible conditions? The answer lies in secret super technology, a combination of advanced stabilization systems, AI-driven navigation, and revolutionary hull designs that allow these warships to defy the ocean's power. 1. The science of balance. Ballast control. At the heart of an aircraft carrier's stability is its ballast control system. Imagine a giant high-tech counterweight system hidden inside the ship. Carriers are equipped with massive ballast tanks, huge chambers that can be filled with or emptied of water. These tanks adjust the ship's center of gravity, keeping it level even as monster waves crash against it. When the ocean turns violent, the system automatically shifts thousands of tons of water between tanks, countering the ship's movements and preventing deadly tilts. It's a constant battle, a split-second adjustment game where even a 2-degree shift can mean the difference between control and chaos. 2. A hull designed to cut through chaos. The design of an aircraft carrier's hull isn't just about size, it's about survival. Unlike smaller ships which ride on top of the waves, carriers are designed to cut through them. Their massive weight and low center of gravity allow them to punch through swells that would toss other vessels like toys. But even this isn't enough. Engineers have developed wave-piercing hulls that reduce drag and break up massive waves before they can impact the ship's stability. Some of the newest designs even use stealth-like hydrodynamics, reducing the resistance of water and improving fuel efficiency, making these carriers faster and more maneuverable in rough conditions. 3. AI-powered navigation. Outsmarting the storm. Modern aircraft carriers are equipped with AI-driven navigation systems that predict, track, and counteract dangerous sea conditions in real time. These systems analyze wind speed, wave height, and ocean currents, calculating the safest routes to avoid the worst of the storm. But when avoidance isn't an option, the AI works with the ballast control system and the ship's propulsion to actively fight back against the ocean. It adjusts the carrier's heading, slows or speeds up movement, and fine-tunes stabilization, all without human intervention. This level of precision eliminates human error, making the difference between a smooth ride and a catastrophic failure. 4. The future. Next-gen stabilization tech. The Navy isn't stopping here. Future aircraft carriers may use active suspension systems, giant hydraulic stabilizers that neutralize wave impact in real time. Researchers are also exploring magnetic ballast systems that move weight at lightning speed, offering even greater control over a ship's stability. Some designs even propose self-healing hulls, materials that automatically repair stress fractures caused by relentless ocean forces, increasing durability and reducing maintenance needs. The ultimate battle. Man versus nature. Aircraft carriers are built to survive war, but their greatest battle may always be against the ocean itself. With these revolutionary technologies, they can withstand waves that would destroy lesser ships. But the ocean is unpredictable, and nature never stops evolving. The question remains: will technology always stay ahead, or will the sea eventually claim even the Navy's most advanced giants? One thing is certain: this battle is far from over. How these technologies work in action aircraft carriers are built to dominate the seas, but what happens when the ocean itself turns against them? Imagine towering waves, violent storms, and unpredictable swells slamming against a 100,000-ton warship. In these extreme conditions, even the most advanced carriers face a brutal test. So how do they survive? The answer lies in cutting-edge technology. Stabilizers, ballast systems, and AI-driven navigation working together to keep the ship afloat and operational. Let's break down how these technologies perform in real-life scenarios. 1. The reality of rogue waves. When nature strikes back. In 2017, a massive rogue wave, a towering wall of water, slammed into a U.S. Navy aircraft carrier in the Pacific. The impact? Enough force to tilt the entire ship and flood lower decks. But thanks to advanced stabilization systems, the ship corrected itself within seconds. How? The ballast control system sprang into action, shifting thousands of gallons of seawater between tanks. This counterbalanced the tilt and kept the ship upright. Gyroscopic stabilizers engaged, using high-speed spinning mechanisms to resist sudden movements. The AI navigation system analyzed the wave pattern in real time and adjusted the ship's heading, minimizing the next impact. Without these systems, a ship of this size could have capsized or suffered severe damage. Instead, the carrier remained steady, allowing flight operations to continue. Second Super Typhoon Challenge. When carriers face nature's fury. During a Category 5 super typhoon, a carrier in the South China Sea had to navigate 50-foot waves and hurricane-force winds. The flight deck was being pounded by rain and seawater, and the ship's entire structure groaned under the storm's force. Here's how the tech kicked in. The AI-driven navigation system analyzed wind patterns and rerouted the ship to avoid the storm's strongest zones. The hull design, engineered to cut through waves, minimized resistance, and allowed the ship to plow forward without losing stability. The propulsion system adjusted speed dynamically, slowing down to absorb impact without being thrown off course. This perfect combination of tech, ensured that the carrier rode the storm instead of being consumed by it. 3. Animation breakdown. The tech in action. To visualize this, let's break it down with animations and real-life footage. Ballast system in motion. An animated cross-section of the ship shows how ballast tanks fill and empty, shifting weight in response to wave movement. Gyroscopic stabilizers. A visual of massive spinning stabilizers resisting external forces, keeping the ship steady even when waves push against it. AI navigation overlay. A side-by-side comparison of a stormy sea and the navigation AI's calculated adjustments, showing how the system steers the carrier through dangerous waters. These animations, combined with actual footage of carriers enduring massive waves, give viewers a real sense of how these technologies fight back against nature in real time. The ultimate test. Man vs. ocean aircraft carriers are built for war, but their toughest enemy will always be the ocean. Without these technologies, even the world's most powerful warships would be helpless against nature's fury. The next time you see an aircraft carrier slicing through the sea, remember, it's not just brute strength keeping it afloat. It's a battle of technology, science, and innovation against the unrelenting force of the ocean. And so far, technology is winning. Why this tech is a game changer for naval warfare. Aircraft carriers aren't just warships, they're floating military bases. A single carrier can control an entire ocean, launching jets, deploying forces, and projecting power anywhere on the planet. But in extreme weather, even these giants face a serious threat. Massive waves, violent storms, and unpredictable ocean currents can cripple their ability to operate. That's why the Navy's stabilization technology isn't just about survival, it's about winning wars. Every system on board, from ballast controls to AI-driven navigation, is designed to keep the carrier combat-ready, no matter the conditions. Here's why this tech is a game-changer for modern naval warfare. 1. Stability equals combat readiness. In war, seconds matter. If a carrier can't launch or recover aircraft due to rough seas, its entire offensive and defensive capabilities are compromised. Imagine a fighter jet trying to land on a deck that's tilting violently due to a storm. One wrong move could mean disaster. With advanced stabilization systems, the Navy ensures that the flight deck stays level, even in 50-foot waves. Aircraft can take off and land safely no matter the weather. Weapon systems remain accurate, since rough seas won't disrupt targeting or missile launches. This means that even in a Category 5 hurricane, an aircraft carrier remains a fully operational war machine. AI-powered navigation. Outsmarting the ocean. Today's carriers don't just react to the sea, they predict and outmaneuver it. With AI-driven navigation systems, a carrier can analyze real-time weather patterns and adjust its course before a storm hits, automatically adjust ballast systems to maintain perfect stability, coordinate with escort ships, ensuring the entire fleet moves together efficiently. This isn't just about comfort, it's about keeping the fleet in the fight. A stable carrier means faster deployment, better logistics, and fewer delays in critical missions. 3. The future of naval engineering. What's next? The next generation of carriers will take stabilization technology even further. The U.S. Navy is already testing autonomous AI-driven ballast control, capable of reacting to wave movements in milliseconds. Future designs might include magnetically controlled stabilizers, reducing drag and increasing efficiency, adaptive hull designs capable of reshaping in response to ocean conditions, real-time satellite integration, allowing carriers to anticipate and avoid storms days in advance. The goal? An unsinkable warship. 4. The ultimate advantage in warfare. In modern naval battles, mobility and precision win wars. A storm can cripple an outdated warship, but a high-tech carrier can cut through the chaos and keep fighting. With advanced stabilization, AI navigation, and next-gen engineering, these floating fortresses are no longer just surviving the ocean. They're conquering it. The future of warfare belongs to those who can control the seas. And thanks to this revolutionary tech, the U.S. Navy is leading the way. The ocean is the ultimate force, Vast, relentless, and unforgiving, it has swallowed entire fleets, crushed the strongest ships, and humbled even the most advanced navies. For centuries, sailors feared its wrath, knowing that against the sheer power of nature, human engineering was powerless. But not anymore. The U.S. Navy's aircraft carriers stand as a testament to human ingenuity, floating fortresses designed to defy the sea itself. While towering waves crash and violent storms rage, these massive war machines stand their ground, refusing to be tamed by the ocean's fury. Through cutting-edge stabilization systems, AI-driven navigation, and next-generation hull designs, these carriers don't just survive, they dominate. No storm is strong enough, no wave is high enough to stop these technological marvels from commanding the seas. But this battle isn't over. The ocean is unpredictable, and with climate change bringing stronger storms and rougher waters, the Navy must continuously adapt. Engineers are already developing even more advanced technologies, ships that can outmaneuver any storm, counteract any wave, and remain fully operational in conditions that would sink any other vessel. Because in the eternal struggle between human power and nature's fury, only one can rule the seas. And with each innovation, each breakthrough, and each new carrier that rolls off the deck, the message is clear. The ocean may be mighty, but the Navy is mightier.